Okay, I'm back. This is part 2 of section 7.5. And this is the last example. It's pretty extensive one. And so I wanted to go over this with you in detail. And then we'll be done. You should be fine with doing the method of partial fractions. So you have an additional integration technique now, which is cool. All right, so we have this example right here. What if you have a repeated irreducible quadratic factor? Okay, I should have put irreducible there, but repeated, it's implied if it's a repeated quadratic that it's irreducible, because otherwise, if you could reduce it down to linear factors, you would. So you don't have to put irreducible there. Okay, so the integral 4 minus x over x times x squared plus 2 squared dx. Okay, so the PFD, we have 4 over x times x squared plus 2 equals, all right, so it's similar to repeated linear factors in terms of you have to build up, but this time, just think if you're either going to have a linear factor or a quadratic factor. So if you have a linear factor above it, you sort of go a degree down. So linear factor has degree 1, so degree 0 is a constant. So that's why we put constants above the linear factors. But now if we have a quadratic, then a degree below quadratic is a linear factor, right? And so that's why we put linear factors. So that's how, be very careful, because a common mistake is to set this up incorrectly. If you set this up incorrectly, then the rest of your work is wrong. And in terms of thinking about when you're getting graded on this, if this part is incorrect, then the rest of your problem is wrong. So you want to make sure that you set your PFD up correctly. Okay, and so if we clear fractions, so we're going to get 4 minus x equals a times x squared plus 2 squared plus bx plus c times x squared plus 2, and then plus dx plus e time, and you should have room, so put it on the same line, but I'm gonna have to go to the other line, times x, just x. Oh, I don't have to really go to the other line, just squeeze that x in, times x. Okay, this is once you clear fractions. Now I'm going to show you, so I'm actually going to use, because we have a lot of different constants we're dealing with, I'm going to use I told you can use either method or you can combine methods. So I'm going to combine methods just to make my life a little, in this case, it's only going to be a little bit easier, but you can't, beggars can't be choosers, right? So 4 minus x. All right. So what I mean by combine methods, remember the first method I showed you is that you look for the zeros of the factors and then use those to eliminate, to solve for some of your variables. So in here, since that x squared plus 2 is irreducible, there's no roots there, right? There's no real roots, I should say. But we have an x there. So we know when x is 0, that's when x equals 0 is one of our zeros. And so we can, and I'm going to try to squeeze it here before I go to the next slide, but when x equals 0, the left-hand side, if we plug in 0 there, it's just going to give us 4. It's just going to give us 4, and then equals the right-hand side. Well, look at this. This entire term goes away, and this entire term goes away, right? And so we're left with a times 0 squared plus 2, so we're left with 2 squared. So that gives us 4 equals 4a, and so a equals 1. All right. So I would, if you're comfortable with sort of switching up methods, or you would like one method more than the other method, some methods it'll be you want to learn efficiency. In mathematics, it's not just about getting the right answers, it's about getting it efficiently. And so in this case, we just got A. Really, that was sort of a giveaway. So now when we write, that 4 minus x again, since A is 1, we can now look at this instead of putting in a, we just put x squared plus 2 squared because we saw for a is 1, right? So we got rid of one of our constants, but we still have the others. So we still have bx plus c times x squared plus 2, and then plus dx plus e times x. So go ahead, stop the video, and do the math, distribute this out. So now we have to use the other method where we sort of balance our equations. So go ahead and do that, and I'll be back. Well, you'll be back, I guess. Okay, so we should have distributed out now, and you have that second line there. So look to see if you agree with me with my second line. And second and third line actually. And then the fourth line, I sort of broke it up. So this is the balancing part, right? And so we look at where's our x to the fourth. So we see we have an x to the fourth here and an x to the fourth there. So when we factor that out, that's 1 plus b. Then we only have 1x cubed, so that's c. And then x squared, we have 1, 2, 3. So 4 plus 2b plus d. And then x, we have 2c plus e. And then we have our 4 right here. And look at that. And it's nice because that's the only constant, right? So that's balanced. So the 4s are already balanced. So we good there. So that tells us what? Well, we don't have any x to the fourth. So there are no x to the fourths on the left-hand side. So that tells us that b plus 1 or 1 plus b equals 0. No x cubed. So c is 0. X squared, let's see, we don't have any x squared, so 4 plus 2b plus d equals 0. And then we have a negative, remember, when you don't see a number, that's really a negative 1, right? So 2c plus e equals negative 1. Okay, and now we just, well, from this, we have b equals negative 1. We know c is 0. So if c is 0, then we can look at this one and say e equals negative 1. Okay, so we're winding down. We're doing pretty good, right? So we have our a, we have our b, we have our c, and we have our e. We just need a d, right? But we can find that out from the remaining equation. So 4 plus b is negative 1, so 2 times negative 1 plus d equals 0. So 4 minus 2 plus d equals 0. So d equals, what's that going to be? Negative 2. D equals negative 2. And we have all our values, and just to repeat and put it all together. So we found on the last slide that a equals 1, b equals negative 1, c equals 0, d equals negative 2, and e equals negative 1. So we can now go ahead and write that back into our... Okay, so I shut off, so I might be repeating this. And if I am, I'm sorry, and you can fast forward, but if I'm not, then good. But so when you do the algebra and work it out, I'm going to go kind of fast because I feel like I'm repeating this, but I don't know. So when you balance off the equations, you get this line here. When you group them together, right? And then to balance the equations, notice that the 2 4s, the 2 constants, we're good with that. And so then we go piece by piece, and b plus 1 or 1 plus b is equal to 0 since there's no x to the fourths on the left-hand side. There's also no x to the third on the left-hand side, so c equals 0. X squared, there's no x squares on the left-hand side, so 4 plus 2b plus d equals 0, and there is a negative 1 on the left-hand side. And we're looking at the coefficients, okay? So I don't know if I said that earlier. We're looking at the coefficients. And so because if you think about it, this represents the coefficient of x, right? So 2c plus e equals negative 1. And you can look at this. Again, I'm sorry if I'm repeating this because I think I did, and then my timer on my video said I wasn't moving. So nevertheless, you can pause this and sort of look at the algebra here. And here's our final values at the bottom. A is 1, B is negative 1, C is 0, D is negative 2, and E is negative 1. Okay. So now we can put that all together. And we have, so the integral of 4 minus x over x times x squared plus 2 squared dx equals the integral of dx over x plus the integral of negative x over x squared plus 2, right? And this was the bx plus c, but remember c was 0, so that's why we have that dx, all right? I don't want to get marked off by myself. And then plus the integral of negative 2x minus 1 all over x squared plus 2 squared dx, okay? And you're going to have to use substitution, and in fact, this will be a nice review for you all to do. Well, here, so this in terms of, this is sort of your side work. So this is sort of the side work to solve the integrals. Okay, so for, I'm going to use this marker, that might be better. Okay. So for here, this is just what our natural log, right? So that's a straightforward. So this is a famous integral. Here, what do you think you have to do? Substitution. Good. Here, you actually need to break that up, right? Because it's not substitution. And so you actually need to break this up. So this is your side work. To negative 2x over x squared plus 2 dx minus the integral of 1 over x squared plus 2 squared dx. And for this one here, you can use substitution. And for here, you would need to use trig substitution. I know, you can't get away from it. But math is so beautiful because it builds upon itself, okay? My suggestion would be this, and this is what I did in my notes, but I'm going to save time because I'm at 12 minutes already, and this is still the first problem, so I'm not going to, you guys know how to do this. So what I would suggest is you do this. In your notes, sort of make, I would mark, let's say, in my notes, I'll call that 1, call that 2, and call that 3, right? And in my side work, so I would do my side work, and I would say, okay, the integral for 1. And just take, so I would take that integral, x squared plus 2 dx, and solve for that. Get that answer, right? And then take 2 and solve for that. All in your side work, so then when you bring it all together as your final answer, you won't have all that clutter. With your side work will be separate, but your final answer will be there. And, you know, it helps me. It's not mandatory because if you just see the integral straightforward, then you can do it. But it helps me if I see your side work, because if you made a mistake, and it could be a simple mistake, but if you make a mistake and I don't know, and I don't have any side work to look at, then I might just take off more points or not give you credit at all because I'm not seeing where you got your answer or where you may have made a mistake. So the side work is important, but keep it as side work because I don't want it to interfere with the main problem. So pause this and actually go through all 3. On the next page, I'm just going to give you guys the answers. I really want you to see if you can work out and put everything together. Okay, so here is, oh my goodness, I know, right? Here is the final answer. And keep in mind, I used the right triangle because on one of those you needed to do trig substitution. The one with trig substitution, I used the reduction formula, and then I used the right triangle. So if you did not use the right triangle, it might look slightly different. But other than that, everything else should look similar. So the integral of 4 minus x over x times x squared plus 2 squared dx is equal to the natural log of x minus the natural log of the absolute value of x minus the natural log of the absolute value of x squared plus 2 over 2 plus 1 over x squared plus 2 plus the square root of 2 over 8. And I put it on 2 lines. I really want to put it on 1 line. So in your notes, you should have enough room to put it on 1 line. Plus the square root of 2 over 8 times tan inverse of x over 2 plus x over 4 times the quantity of x squared plus 2 plus c Yes, I know this was a lot, but hopefully you guys got the same answer. If not, go back over the notes and we are done. So this will actually, this is for Friday and this is for Monday. So that means we're moving forward. When I come back on Wednesday, we are moving forward to 7.6. So make sure you go over this and write down any questions you may have. And I might either do another video to answer those questions, or I don't know if I'll do it in class because I want to move on to 7.6 by Wednesday. But yes, so make sure if you have any questions, write them down. But make sure you go back over the video as well. All right, see you guys later.